You've probably heard someone call compound interest the eighth wonder of the world. Sounds pretty big, right? But what does that actually mean for your money, for your savings account? Well, it's this quiet, powerful force that can turn even small savings into a serious nest egg over time. So in the next few minutes, we're going to pull back the curtain, demystify the whole thing, and give you the exact tools to see for yourself how your savings can grow.
Here's our game plan. First, we'll get into the so-called magic of compounding. Then, we're going to gather up all the key ingredients you need for the calculation. We'll walk through a basic example first, then we're going to level up and add regular contributions. And finally, we'll tie it all together to see what this really means for your financial future.
All right, let's start with the magic of compounding. You know, it's a surprisingly simple idea, but really getting it is the absolute first step to unlocking its incredible long-term power.
Okay, so at its heart, it's this simple. Compound interest is just interest that starts earning its own interest. The best way to think about it is like a snowball rolling down a hill, right? It starts off small, but as it rolls, it picks up more snow, gets bigger, and starts moving faster and faster. That's your money literally working for you.
So to actually calculate this amazing snowball effect, we need to get a few key pieces of information together first. Think of it like a recipe. We need to gather our ingredients.
We've got 4 core components we absolutely need to know: the principal, the annual interest rate, the compounding frequency, and of course, time. Let's quickly break down what each of these really means.
First up, P is for principal. This is just your starting point. It's the initial chunk of money you put in, or whatever the current balance is in your account. For our examples today, we're going to start with a principal of $2,000.
Next is R for the annual interest rate. This is the percentage your bank or investment pays you every year. But here's the really crucial part for doing the math. You always have to turn this percentage into a decimal. So, for example, a 1.2% interest rate becomes 0.012.
Then we have N, which stands for compounding frequency. This is all about how often the bank actually runs the numbers and adds the interest to your account. So if it compounds quarterly, N is 4. If it's monthly, N would be 12. And yeah, the more often it compounds, the faster your snowball grows.
And finally, T is for time, and we measure it in years. Honestly, this is the secret sauce. The longer you can just let your money sit and work, the more jaw-dropping the effects of compounding become. We'll use a 10-year period for our first calculation.
All right, we have our ingredients. Let's jump in and do the basic calculation to see how a single deposit can grow over time, completely on its own.
And here it is, the classic compound interest formula. Now I know it might look a little intimidating, but it's really just putting our 4 variables to work. That A on the left represents the final amount you'll have in the account. That's your principal plus all the interest it's earned along the way.
And here's where it all comes to life. We just plug in our numbers, right? Our $2,000 principal, our 0.012 interest rate, compounded 4 times a year for 10 years. As you follow the math down, you can see our future value comes out to $2,254.58.
So, there you have it. After a decade, without you lifting a finger, your initial $2,000 has grown to just over $2,200.
That means your money earned $254.58 completely by itself. That's the power of letting your interest earn interest. But what if we helped it along a little?
Because that was just letting our money sit. Now it's time to level up. This is where things get really exciting, because adding regular contributions is how you seriously supercharge this growth.
Whoa, okay, this new formula looks like a beast. But don't worry, the first part is the exact same formula we just used. That calculates the growth on your initial principal. This whole new second part, that's what calculates the future value of all your regular contributions, which we call PMT for payment.
So let's try a new example. We'll stick with our $2,000 principal and the 10-year timeline. But this time, let's say we're compounding monthly, so N is 12, and we're going to add a PMT, or payment, of $100 every single month. Now, the first part, our principal growth, is pretty much the same. But just look at that second part. Our monthly $100 contributions grow to over $12,000 on their own.
And when you add those 2 parts together, your account value just skyrockets to nearly $15,000. I mean, look at that difference. That right there is the power of consistency.
So let's look at the interest earned here. You put in your first $2,000 plus $12,000 in contributions over the 10 years. That's a total of $14,000 from you. That means you earned $997.86 in pure interest. That's almost 4 times more than in our first example.
So this brings us to the big finale. What does all of this actually mean for you? Let's just visualize the impact of these two different approaches side by side.
When you see it like this, the difference is just staggering. On the left, that's the result of letting a lump sum grow all by itself. And on the right, that's the incredible result of adding small, consistent contributions. It's not even a contest.
And that's the real takeaway here. Yeah, a good interest rate is great, but the true engine of creating wealth with compounding is your own consistency. Those regular contributions, they're what feed that snowball and make it grow exponentially. So, we've walked through the magic, we've gathered the ingredients, and we've done the math. You now have the formulas to map out your own financial growth. The only question left is, what are you going to build with them?